Hello everyone. Welcome back. I'm guessing you guys are thinking, API? For real? Now that we were just thinking this was going to be a straight out of the box, click of a button type of course for ETABS. Why are we even talking about API? I don't have any programming skills. Do I need to be able to code to use ETABS? The answer to all these burning questions you have is, no, you don't need to have any programming skills to use ETABS. ETABS has actually been around since the 80s, and the first version of the API for SAP 2000 was implemented no longer than 10 years ago, and even more recently for ETABS. That being said, having at least some scripting knowledge is a skill guaranteed to help you in automating and expediting your daily basis work. Even if you never had any experience with scripting, and though we will not attempt to teach you how to code on this lecture, we still strongly encourage you to follow the contents of this video. We'll show you how to access ETABS through its API, and explore simple operations, similar to the ones we have been introducing in preceding videos, thus hopefully allowing you to follow the contents with ease. We prepared the lecture in such a way that you'll be able to follow the example step by step, to help you in understanding what is happening at each given moment. We know that overcoming the learning curve of using a new piece of software can always feel a bit overwhelming and intimidating, but our goal is to make this so easy for you, that after the lesson and even if you didn't code till today, you'll most probably decide to start now, with a view to make use of all the potential you now know you have at your fingertips, with ETABS plus its API. Having said that, if you believe programming is definitely not for you, then you can just skip this lecture and continue following the next videos of the course, where we'll be reverting back to much simpler operations. If you're new here, please don't forget to subscribe. On previous lesson we had the opportunity to explore how to use the ETABS interactive database, in order to expedite repetitive tasks, and manipulate large quantities of data in an efficient and straightforward fashion. On this lecture, we will introduce you to the ETABS API, with step-by-step examples, that you can reproduce at your leisure, thus aiding you in fully understanding how to work with the API. Here's what you can expect to learn on this video. We'll start with a brief introduction of the API, so you understand its purposes and advantages. We'll then proceed to show you where all the API documentation is stored, and how you should continuously refer to it while using the API. This will include a brief description of the object-oriented API structure, overview of some of the classes and enumerations embedded with the API, with focus on the ones we will use on the lecture. Lastly, we'll revise class properties and methods, plus information available for each method. For lack of a better word, we'll dissect the example that comes integrated with the API documentation, with the goal of exposing you to the basic operations you need to know, so you can work proficiently with the API. This will be followed by step-by-step worked examples. Main topics presented include how to launch ETABS from the API, or use a current instance of ETABS to run your code. How to select which version of ETABS you want to use, when more than one version is installed on your machine. Initializing a new model. Create a grid-only or a NewSteelDeck template model. How to save your ETABS model, including the EDB and E2K files, plus all the files generated during analysis of the model. How to perform checks on the code, to investigate if the API functions worked as expected. AddMaterials, sections and frame objects. RunAnalysis. Close ETABS. And how to access the tables of the interactive database through the API. Let's get started. An essential tool in modern software development, which is offered by CSI, is our Open Application Programming Interface, or API, which is embedded for free with the software installation, and which is intended to facilitate integration between ETABS and many other different software systems, allowing them to communicate and share data seamlessly. The development of in-house tools, with a view to increase efficiency and minimize human error, plays a critical role on the overall production process and the final project quality. With our API, users are given the possibility of expediting their workflows, by creating their own in-house tools, for instance to generate templates, which interface allows users to parametrically add commonly used structural components to their models. Automate and configure pre-process requirements, including presetting any specialized loading and analysis requirements. Streamline your design process, by building customized algorithms that implement specific design checks. Moreover, if you already have your own in-house tools, whether spreadsheets or full-blown applications, you can use the CSI API to connect these tools to CSI software. Third-party developers, such as CAD and 3D modeling developers, are given the possibility of largely enhancing the power of their applications, by enabling direct, fast and efficient access to all of the advanced numerical methods of CSI software, all from within their applications. The CSI API allows tight bidirectional transfer of information, without intermediate files, providing accurate transfer of models, complete control of execution, extraction of analysis and design information, and fast integration even for large models. If you're a developer, we recommend you visiting the Developer tab of the CSI America webpage, where you will find some useful information on how to connect your applications with CSI software through the API. And we also invite you to navigate to the Third-Party Applications tab, and check the list of existing plugins that we advertise on the webpage, with emphasis for instance on the one from Geometry Gym, that allows integration with Rhino and Grasshopper, and Idea Statica, which offers steel connection analysis and design. If you browse to the installation folder of the software, you'll find the CSI API ETABS v1 help file, which includes all the documentation you may require to start using our API. If you want to use the API proficiently, it is of paramount importance that you familiarize yourself with the API documentation, as it illustrates how to connect to ETABS using the API from a variety of clients. Besides an introduction and release notes, it includes some pages with key concepts, to which we'll refer to in due course. This is followed by an application example to get you started, using different programming languages, notably VBA, MATLAB and Python. Below the examples, you find the ETABS v1 namespace. This is what can in fact be considered the API. It comprises the complete and alphabetically organized list of classes of the API, followed by the list of enumerations. The API includes dozens of classes, each one incorporating their own properties and methods. We don't expect you to straightaway know all the classes and methods available, but with time, patience and experience, you will become familiar with the structure. This video is thus intended to get you started on that path. On that note, we prepared the table on screen to let you know for which classes we will illustrate usage on this lecture, and for those, which of their properties and methods we will showcase. Moreover, the table should also aid you in understanding the precedence of classes. As an example, classes file, material properties, frame properties, and frame objects are all properties of the SapModel class, which is the class you will use to create your EtabsModel object, thus allowing you to access all the methods of these classes, such as creating a new grid-only model, saving the model, adding materials and section properties, adding frame objects, running the analysis, etc. Likewise, the cSAPModel class is a property of the cOAPI class, called SapModel. Besides the classes just mentioned, we will also have the opportunity to demonstrate usage of enumerations. The examples will include the units and the material type enumerations. All of the API functions are thoroughly documented in the Searchable help file. For each function, the documentation includes a description of the function syntax, a list containing the description of each of the function parameters, which is of the utmost importance to correctly use the function. Please notice that all API methods are in fact defined as functions, which mean they return a value. All ETABS API functions are expected to return a 0 value when correctly executed. Any important remarks, which are basically notes to inform the user of any particularities of the function, and how some data will be interpreted and used. And lastly, a function application example, quite handy to give you some idea on how to specify it later on your code, including the types and number of parameters the function is expecting. One of the reasons why we thought we should introduce you to the API at this point, is that currently users can take advantage of a new set of database tables, that offer extensive table editing capabilities of the ETABS Interactive Database, a feature discussed on previous lecture. More information on how to access the tables, and how to work with the functions of this class, is described on page Database Tables for Editing and Display, of the API help documentation. For a more thorough description of the possible database table operations, please refer to the individual function documentation, made available in C Database Tables. Before using this capability for the first time, it is recommended that users familiarize themselves with the database tables using the ETABS user interface, in terms of how data can be requested, viewed, modified, and applied to the model. Please refer to precedent lecture on this training series for more information on how to access the interactive database tables in ETABS. Please note that the purpose of this chapter is not teaching you any programming skills. We would need another specifically oriented course for that purpose alone. Assuming you are using the API for the first time, our recommendation is that you start by loading and executing the example code that comes with the API documentation, which we mentioned just a few moments ago. The reason this is a good starting point is that it will give you a sense of the steps required to access the API and understand how to call its functions, which can then be used to perform a variety of operations in ETABS, such as launching the software, initializing a new model, creating a model, running the analysis, and then closing the software. For simplicity, we'll use the VBA example, just because the Visual Basic Editor will be readily available to everyone inside Excel. Start by saving an Excel file with format Microsoft Excel macro-enabled workbook. Also, make sure you enable the Developer tab on your ribbon. If it's not visible, then go to File, Options, Customize Ribbon, and activate the Developer checkbox. Go to the Developer tab and access the Visual Basic Editor. Add a new module, where we will store our code. Let's call it API example. Make sure to add the ETABS API under the references. For that purpose, go to Tools, References and look for the ETABS Application Programming Interface API v1. Make sure to activate it. Revisit the API documentation. Look for the example code, using VBA. We'll reproduce this example step by step with you, so that you understand how to work with the API. Copy the complete procedure, and paste it on the VBA module. The code is comprised of only one sub-procedure, called main, where all the instructions will be given. If you're not used to scripting, I'm guessing you might be looking at all these lines of code and getting a little frustrated that you don't understand a thing, but I'll make this so easy for you, I might just get you hooked in to start coding yourself. Let's use breakpoints every time we want the code to pause, to give us time to understand what's happening. We'll apply this first one just as we declare the first variable of the procedure. Hit the Run Subroutine button to start executing the code. The first variable declared, called AttachedToInstance, can take values true or false. If you read the comments on the code carefully, you'll see that it is simply used to specify whether you want the procedure to run using a current instance of ETABS, in which case the variable should be set to true, or if you want the procedure to launch a new instance of ETABS, in which case the variable should be set to false. On the example, the variable is set to false, which means that a new instance of the program will be launched. Add a new breakpoint for the second variable. Click the Step Into button of the debug toolbar of your VBA editor, so that the program executes one more line of code. The next part of the code refers to the version of ETABS you want to use when executing the procedure. As a reminder from Lecture 1, we mentioned that several versions of the software can be installed and coexist on the same machine. Same as previous variable AttachedToInstance, this new variable specify path will also only assume values true or false. When the variable is set to false, as is the case of the example, then the program will by default launch the latest version of the program currently installed on your machine. If you change this to true, then the program expects you to specify the path where the version of ETABS you prefer to launch is installed. That is in fact the purpose of the next variable program path. Because this example is just set to launch latest version of ETABS by default, the program path variable is currently not in use, and is commented on the code, so that when executing the procedure, the code basically skips this information. Add one more breakpoint. Click the Step Into button of the debug toolbar of your VBA editor, so that the program executes one more line of code. As mentioned on previous lecture, we recommend creating a dedicated folder to store all the files generated when saving and executing an ETABS model. With that in mind, the model directory string variable is used precisely to specify the path and name for this directory. In the example, the procedure is telling you that the new folder will be created on your C drive, with name CSI ETABS API example. Next, the code uses a conditional verification to check if the directory already exists, and if not, then the procedure uses the VBA function mkdir to create a new one. If you execute the code step by step, you can actually see when this folder is created on your C drive. Now that you already have the folder where you'll save the model, the next step is to give your EDB ETABS file a name. That's what the string variable model name is for. In our example, the name of the EDB file will simply be ETABS API example. You will also want to specify where this file should be stored. The string variable model path is thus used to indicate that the EDB file for this example should be saved inside the directory created a moment ago for that effect. Up until now, all the instructions were simply Visual Basic, meaning they were not specifically related with the use of the API, but the next part of the code is where you really start accessing the API classes and methods. Please refer to the API documentation page, examples, overview, for a description of the steps required to connecting to ETABS through the API. Start by creating a new object called myHelper, of type cHelper. For more information on this class, browse the API documentation, and check methods available for the cHelper interface. The ones you'll probably use on a regular basis are the CreateObject and the GetObject, which will respectively allow you to start the program at a given path, or attach the object to a running instance of ETABS. Execute one more line of code, now to dimension the ETABS object as cOAPI type. Let's once again navigate to the API documentation, so we can check properties and methods available for this class. Of interest under the cOAPI methods, you find the application start and the application exit, to respectively start and exit ETABS. Please also notice as the SapModel is a property of class cOAPI. During the lecture it will become apparent as the cSAPModel is perhaps the most important class of all the API, as it is the one that gives you access to the majority of other API classes and their methods. Let's move the ret variable a few lines below, as we don't need it declared at this point. We'll discuss that one a bit later. As a reminder, a few moments ago, we set the variable attached to instance to false, which means the procedure will force ETABS to launch a new instance. Check the API documentation page, attaching to a manually started instance of ETABS, for a full description on how to specify if you want to use the current ETABS instance, or launch a new one instead. Once the attached to instance variable is set to false, we are on this part of the conditional statement. Here the procedure decides which version of ETABS to launch, based on the value set for the variable specify path. For latest information on updated code for this method, please check the API documentation page, launching the installed version of ETABS automatically. We remind you that we set the specify path variable to false above, which means that the procedure will by default launch latest installed version of ETABS. On this next line, we're basically instructing the procedure to launch ETABS. As a reminder, just a moment ago, we've shown you that this is a method of the cOAPI interface, called application start. As soon as you execute this line of code, ETABS will launch automatically for you. And there it is, a new instance of ETABS has now been launched as expected. We'll just minimize for the time being, so that we can continue to follow the VBA routine. Create a new variable, which on the example is called mySapModel. We cannot stress enough the importance of this variable, but it will become apparent on the following lines of code. This is the variable responsible for allowing you to access all the API classes and functions. All the API methods are in fact defined as functions, which mean they return a value. The variable ret is defined to store the return value of any calls to the API functions. Please also note that you can check the return value of each API call, as we'll show you in just a minute. A returned value of 0 indicates the function executed as expected. Any other value means something went wrong, and you might need to debug your code. Execute one more line of code. The procedure is now calling function Initialize New Model from the API, which is a function from the cSAPModel interface. As just described, please note as we are using the ret variable just declared, to store the return value of the API function. Let's have a look at what that function looks like on the API documentation. This one will be listed under the methods available for the cSAPModel interface. If you revise it, the description lets you know that this function clears the previous model, and initializes the program for a new model. The only parameter for this function is optional, and refers to which units you want to use when starting your new model, which wouldn't be too different from what you'd do when starting your model directly on the user interface. The units parameter is defined as an enumeration on the API. At the moment, no value was given for this parameter, so when executing the code, the program will assume present units. If you want to specify your own set of units, then use the corresponding number of this enumeration, and add it inside the brackets of the function on the VBA code. Execute the line of code. Confirm that ETABS has now prepared a new model for you, as expected, using default set of units. And also that the ret variable is returning 0, which lets you know that the API function executed correctly. The example from the API continues now with instruction to populate a template model on screen, the NewSteelDeck one. You'll notice that we now have the code side by side with the current instance of ETABS. As soon as we execute this line of code, we'll see ETABS populating the model. Let's again investigate how the function looks like on the API documentation. If you don't know what class has this method, a good option is to browse the index tab for the NewSteelDeck function. This allows you to confirm the method is available under the cFile interface class, which offers the following methods: export file, get file path, import file, new blank, new grid only, NewSteelDeck, Open file. And save. By now you should be able to recognize most of the commands listed, as these were topics covered in previous lessons. You should remember the templates window, for instance, where we've shown you how to start a new model using a blank canvas, the traditional grid-only option, and also the additional template models, from which we have been using the flat slab with perimeter beams on our examples. The API example is using the NewSteelDeck. As it is, the one we have been using on the videos is not currently available as an API call. I gather CSI added the NewSteelDeck template for the sole purpose we have been using the flat slab with perimeter beams, that is, to allow users to easily be able to create a complete and stable model, ready to go for analysis, from within the API. That being said, CSI is continuously adding additional functions to the API, so it could be that this list will expand to accommodate the other template models in the future. Check the description of the several parameters of this function, which include the number of stories, the typical story height, the bottom story height, the number of grid lines in the X direction, the number of grid lines in the Y direction, and the spacing in both X and Y directions. You can confirm on the procedure that all the parameters were given to the function. We also recommend you to have a look at the example code provided for each function on the documentation, especially if you will be using it for the first time. Back to VBA, execute the line of code and see how ETABS generates the model for the NewSteelDeck template. Check again that the return value of the function is 0, as expected. As mentioned before, a return value of 0 indicates the API function was successfully executed. The next line of code instructs to save the model inside the folder previously created for that effect. As a reminder, the path to the directory is stored on variable model path. Let's have the directory open side by side with the code. As soon as you run the code, you'll see as the model is saved inside the CSI ETABS API example folder, on your C drive, with name ETABS API example. You can see both the EDB and the E2K text files. From previous lectures, you know that the save command is found under the file menu of the interface, which should give you some idea of where to look for the corresponding method on the API. In this case, we reviewed this just a moment ago, when looking at the list of available methods for the cFile class of the API, where one of the available methods is precisely the save. Before moving forward, just want to quickly raise your awareness for two aspects. The first one is once again checking that the return value of the API call, stored on variable ret, is 0 as expected. I know I'm starting to be a bit repetitive with this one, but this is a check you should always perform when using an API function, so I might as well make sure you remember this right from the start. Secondly, when we created the MySAPModel, we mentioned how important this variable would be. Please notice as this variable instances the cSAPModel class, which, as we've been stressing, it's the class that allows to reference all other API classes and functions. Please notice as each model operation just performed, such as the Initialize model, the Create a NewSteelDeck template, and just now the Save the model, all require an API call, using the MySAPModel, which references the cSAPModel class. We are now ready to run the analysis. We haven't yet performed this operation on the ETABS user interface, but we're proceeding from the assumption this is something you understand, as being the purpose of creating the finite element analysis model. Ultimately, the goal of preparing the ETABS structural model is assembling its global stiffness matrix and solving the equilibrium equations for any specified number of loads. If you were working over the ETABS interface, you'd use menu Analyze, RunAnalysis, for this purpose, and this is precisely what we are instructing the code to do next, by using the API function analyze.runAnalysis. As a reminder, one of the advantages of the template models is that they're ready to go for analysis. By default, if no other loads are applied to the model, the software will at least be able to run two load cases, those being the self-weight or dead case, and a modal analysis based on eigenvectors. These analyses depend only on intrinsic properties of the structure, including its mass and stiffness, which explains why ETABS is always capable of calculating them automatically for any model. ETABS also has load case live defined by default, but no loads have been assigned using this load pattern, so this case will not have any results. Execute the line of code to start the analysis of the model. Check as the program starts creating the analysis model, displays the analysis monitor while running, and finally the locker gets locked, indicating that analysis is now complete and results are now available for the model. You could extract analysis results, including forces, displacements, stresses, etc., and eventually proceed to design the structural elements, all from within the API. This example doesn't explore extraction of results, and it is still out of scope for us. as we haven't yet had the chance to discuss these steps on the user interface, but that would potentially be your next course of action. API methods for extracting analysis results can be found under the cAnalysisResults class, which we recommend you explore at your leisure. Note as all the files generated after running the model are populated inside the folder we created for that effect. Check that the variable read is 0, indicating that the function ran without hiccups. Run the next line of code. The next line of code instructs the software to close. Please note as this function has one parameter, which is set to false on the example. Let's investigate what this parameter is used for. As a reminder, the application exit is a function of the cOAPI interface. If we load the information of the function, we can check that the parameter of this function is this file save, which can only take values true or false. The description indicates that if you set the parameter to true, then the existing model file is saved prior to closing the application. On the example, the variable is set to false. We just finished running the analysis, and the model is saved automatically as soon as it finishes being executed. The code doesn't perform any other operation after running the analysis, so you don't need to resave the file. That's why the parameter is set to false on the example. It is always recommended that you set your objects to nothing when they're ready for destruction. That's what the procedure is doing on these two lines of code, when setting both the mySAPModel and myETABS object to nothing. As you may have already noticed, a final note to stress that, while using the API, we are continuously checking its documentation, to make sure we understand how to use each function correctly, which parameters it expects, and for checking any other remarks or important information about each function. As a final step, the example uses a VBA buildup message to let you know if the code executed successfully, based on the current value of the ret variable. Proceeding from the assumption the code ran as expected, the current value of the ret variable is 0, in which case the conditional statement issues the pop-up screen message, API script completed successfully. If ever otherwise, then message API script failed to complete is displayed instead. This message is helpful for a lot of purposes. One of them is that if you just push play on the routine, ETABS can launch in the background, populate, run and close the model, all almost even without you noticing anything had happened. At least when you get the message, you know if everything executed as expected. This concludes our revision of the API documentation example. Time to roll up the sleeves and develop a few examples of our own. We'll keep it simple, focusing mostly on operations we already covered how to perform on the ETABS user interface, including loading materials from database, adding a concrete rectangular frame section, adding a frame object, and finally assigning a section property to it, using 3 possible different options: when adding the frame through the API, assigning a section property through the API, and by accessing the tables of the interactive database through the API. Let's get started. Start by adding another module on your VBA project, and let's call it Worked Example. On this new module, add a new procedure, called Second API Example, where we'll store the code for this worked example. You'll notice as we have the example from the API documentation side by side with the VBA editor. The reason is that we're going to reuse as much of the information as possible, with the goal of making sure we don't forget any of the steps covered on the previous chapter of the lecture, particularly in what concerns setting up the required objects to access the API calls. This will also hopefully help us getting a code that runs without errors. Here we go. Step 1. Use the boolean variable attached to instance to decide whether you want to use a current instance of ETABS or launch a new one. Step 2. Use the variable specify path to decide whether you want to use latest installed version of ETABS, or if you prefer to select which version to launch instead. Step 3. Create a dedicated folder to save your model. Let's call it CSI ETABS API Example 2. Step 4. Give your model a name and indicate where it should be saved. Let's call our EDB file ETABS API Example 2, and save it inside the folder just created for that effect. Step 5. Start by creating the API helper object. Secondly, dimension the ETABS object as cOAPI type. We can copy the full conditional statement to verify if we want to launch a new instance of ETABS, or use a current one, and to decide which version to launch. We'll use the same options as the documentation example, that is, launch new instance of ETABS, using latest version installed. If you want to consider launching other installed versions, remember you'll need variable program path. Step 6. Please notice as we already copied the instruction to launch ETABS. If you execute this line of code, a new instance of the software will be launched. Step 7. get the reference to the cSAPModel interface, in order to access all API classes and functions. The documentation example calls this variable mySAPModel, once the example was originally created for SAP 2000, but for consistency, from now on, we'll call it myETABSModel. Step 8. Create the ret variable to store the results of all the API calls. Step 9. Use the Initialize New Model function from the API to create a new ETABS model. Be mindful of the new name of the new variable myETABSModel. If you forget to change the name here, you'll get a compilation error. As a reminder, this function has an optional parameter, which is the units. This time, instead of using default units, we'll force ETABS to create the model using kilonewton meter units. Check the units enumeration page to confirm that for kilonewton meter units, the parameter should be set to 6. From this point onwards, we will be calling some new API functions, but to make sure we can test the code every time we add a new instruction, for step 10 of current example, we'll refer to step 13 from previous chapter, which basically instruct to close the ETABS instance in use, and set both the myETABSModel and the myETABS object to nothing. For step 11, we'll create a new model, using the grid-only option. As a reminder, similarly to the NewSteelDeck function used on the documentation example, the new grid-only function of the API is embedded with the cFile class. The syntax of the function is very similar to the one of the SteelDeck template, to the extent that the function parameters are the same, including the number of stories, the typical story height, the bottom story height, the number of grid lines in the X direction, the number of grid lines in the Y direction, and the spacing in both X and Y directions. Up until now we have been mostly copying instructions from the example code, but we'll write the next set of instructions ourselves, so this is going to become slightly harder, hopefully not by much. We already know that we are using the variable ret to store the return value of any API call. To call an API function, we use the myETABSModel object to get a reference to the cSAPModel class, which, as a reminder, gives you access to all API classes and functions. Assuming the variable is written correctly, when you hit dot after the name of the myETABSModel object, you'll be able to access all the properties and functions that are referenced through the cSAPModel interface. Instead of just typing the code, we recommend you taking advantage of the VBA dot operator. As soon as you write the name of the object, when you hit the dot operator, the drop-down list is displayed, listing all the properties the object can access, followed by the list of functions the object can call. This is a good practice, as it instantly gives you indication that the object is able to reference its class, and it's working as intended. You can then confirm on the API documentation that these are all references to the cSAPModel interface properties and methods. Reverting back to our example, we know that we want to instantiate the file class, so we can call function create a new grid-only model. Next you need to specify the function parameters, which we revised a moment ago. As soon as you open the parenthesis, VBA displays the list of expected parameters, including their names and types. For illustrative purposes, let's consider a 4-story grid-only model, with stories being 3 meters high, including the bottom story. We want similar number of grids in both X and Y directions, say 5 meters for each direction, with spacing of 4 meters, also in both directions. Close the parenthesis and enter. And that's it. Remember to test your code while you build it. That's what we're going to do next. Before adding any further instructions, let's confirm the procedure is running without errors, and that the return value of the latest used API function is 0. Add breakpoints at each API call, so we can check their return values on variable ret. Hit the run procedure command. ETABS is launching as expected. Execute one more line of code to initialize the model. ETABS sets up the new model. Check that the return value of the ret value is 0, as expected. Run one more line of code. ETABS generates the grid-only model, with expected number of stories and grids. Confirm ret value is 0. Close the software and release the objects. Now that we have confirmed we have a code running without errors, the next operation we want to show you how to perform is loading materials from the ETABS material library. Though we haven't yet shown you exactly how to load materials from the database into your model using the ETABS user interface, this is a very simple operation. Let's use our code to create a grid-only model, which we'll use to check that ETABS loads a few materials into the model by default. The material properties are available under Menu Define, Material Properties. When launching the software from the API, these are always US materials, but when launching the software the usual way, and as mentioned on our first lecture, you can load materials pertinent to your region. We will use the API to load a steel material from Eurocode 3, and a concrete material from Eurocode 2. Please note as you can select these on the ETABS user interface, and all the different grades are available. Please make a note of the designation ETABS uses for Eurocode 3, and for Eurocode 2, as we will need to specify these in a minute, when using the API function to set the corresponding material property. Hit the Run subroutine on VBA to close ETABS and release the objects. Launch the API documentation and let's investigate new class cPropMaterial, which is the one that will offer method to add a new material. When using any API function for the first time, it is always recommended that you check the documentation, so you can understand the function syntax, the parameters it requires, any specific remarks to account for, when using the function. And finally revise the example. Before writing the code, some housekeeping notes, regarding the parameters of this function. ETABS assigns a default name to each property and object of the model. Unless the user specifies a different name for the property or object, ETABS will use the internal defined name. Please notice as the documentation mentions this parameter is returned by the program. Also, on the function syntax, this argument is passed to the function by reference, by ref. The arguments of a function can be passed by reference, by ref, or by value, by val. More information on function arguments passing mechanisms is described on page, Programming Concepts Used in the CSI API, of the Key Concepts documentation. We'll declare a string variable called material name, to store the ETABS default material name. The material type is an enumeration, which you can check on the documentation. Steel can be identified by number 1, concrete by 2, etc. We will use Europe for region, but this can be checked on the materials library, which can be found on the installation folder of the program, Property Libraries, Materials directory. For the standard parameter, make sure to use the designation of the design codes, as mentioned a moment ago on the user interface. The grade is a string, indicating the material grade to use. We will set this to S275 for steel, and C4050 for concrete. From the list of materials embedded on the library, it is the grade information that is used to indicate which one to load on the model. Lastly, use the username parameter to indicate any user-defined names for your material, which will supersede the default name assigned by the program. For materials imported from libraries, it makes sense to use program default names, and that's what we'll assume on the example. Please notice as this parameter is optional, so we'll basically skip it when writing the code. We are now ready to write the code. The first thing we're doing is just adding some comments on our code, to help us read it at a later stage. This includes comments on operations performed on previous steps 10 and 11. Let's also add a comment for current step 12, where we will be adding materials from ETABS database, starting with a steel material from Eurocode 3, grade S275. Declare the material name string variable, which will store the name of the material returned by ETABS. Variable ret now equals my EtabsModel, instantiating class cPropMaterials, function AddMaterial. As soon as you open the parentheses, VBA lists the expected function parameters, starting with the name, returned on material name variable just declared. This is followed by the material type, which we will set as 1. As a reminder, material type is an enumeration on the API, and steel is represented by number 1. We will use Europe as the region for both materials we will load on the model. Remember to have a note with the name of the standard you want to use, written in the exact same way as displayed on the ETABS user interface window for the material property. Otherwise, the API will not recognize the material, and, though you will not get a compilation error, the material will not be loaded on the ETABS model. The next parameter is the grade, which we will define as S275. Remember this is the parameter that the API uses to go to the Eurocode 3 library of steel materials, and select which one to load on the model. If you spell the grade incorrectly, or in any way differently from what is used on the material database, you will not get a compilation error. In fact, the API will still be able to load a steel material from Eurocode 3 on the model, once it recognizes the standard, but it will be a default grade, usually the steel S355. As mentioned before, the username parameter is optional, and when specified, it supersedes the default program name. Once we're loading materials from the material library, which are designated based on their grades, we'll rely on program default names for the materials, which are returned by the program on parameter name. We'll thus skip the username parameter. Close parentheses and click Enter. Specifying the concrete material should now be quite straightforward. Add another comment on the code, so you know this next instruction refers to adding a concrete material from Eurocode 2. Start by using variable ret to store the returned value of the API function. Use the ETABSModel object to call API function from the Material Properties class, called cPropMaterial interface, function AddMaterial. Same as for steel, we're using program default name parameter. This time, instead of using the numbers from the enumeration, we're just directly selecting the material from the drop-down list, which is just another manner of performing this operation. We will use Europe as the region. Remember to be careful when typing the name of the standard. That has to be an exact match with the ETABS user interface material property window, for the program to be able to access the corresponding material library. We're loading concrete material with grade C4050, just to make sure it is not the one ETABS usually loads by default, which is the C3037. We're skipping username argument, so as it doesn't overwrite the program default name. We are now ready to test the code. Make sure to add breakpoints before ETABS adds the new materials, so we can check step by step as each of the materials is loaded, and that the return value of each API call is 0. Hit the Run Subroutine button on VBA. The executed code prepares a grid-only model for you, with default US materials, as you can check under Menu Define, Material Properties. This is important so you can make sure that at this point, the model doesn't have any of the materials we will add on the next steps. Confirm ret variable is currently 0, which corresponds to the return value of previous API call, add new grid-only model. Check as currently the material name variable is empty. Run one more line of code, to add the steel material. Revert to the Define, Material Properties menu of the ETABS interface, to check that you now have steel S275 listed, and you can confirm all material properties have been imported from database, including the grade, which is the S275. Please note as the program default material name is the same as the material grade, that being the reason we decided not to use a user-defined name for the material property. In fact, you can check that the material name variable now assumed the S275 program default return value. Confirm the ret variable is 0. Run one more line of code, to add the concrete material. Revisit the Material Properties menu of the ETABS interface, to check that you now also have concrete C4050 populated on the list, with all material properties loaded from Material Library, including the grade, which is the C4050, as expected. Material name is program default, and is the same as the concrete grade. This will be the returned value of argument name of the API function, as you can check on code. Confirm the ret variable is 0. Close the software and release the objects. This concludes step 12 of our worked example. Let's add a few comments on the code, so it will be easy to read it at later stage. The next operation we want to show you how to perform through the API is creating a rectangular concrete section. We will use the same as the example of the interactive database, shown on previous lecture, the C30x40, using the concrete material we just added from database, the C4050. As you should be used by now, the first thing we need to do, is browsing the API documentation, and look for the class that offers the function to add a rectangular section. Rectangular sections are properties that you can define and assign to a frame object. This should help shed some light on why the class of interest for this operation is the one called cPropFrameInterface, where besides a variety of other types of frame section properties, you will find the method setRectangle. Let's load the documentation for the function, so we can revise its syntax, parameters, remarks if any, and application example. In order to help us understand the parameters required for this function, we have the function documentation side by side with the definition of a rectangular frame section property on the ETABS user interface. Let's revise the parameters one by one, starting with the name. This one is self-explanatory, it's basically the name we will use to define the section property. In our example this will be the C30x40. Next we must specify the material. We'll use the Eurocode 2 concrete that we added to the model in previous step. This is concrete grade C4050. The parameters T3 and T2 stand respectively for the depth and the width of the section property. This terminology is slightly different from the one shown on the ETABS user interface, and the explanation is that this comes from SAP 2000, for which the API was originally developed. When working with SAP 2000, all the input data must be specified using units consistent with the model predefined set of units, kilonewton meters in this case. This could be a potential pitfall when using this API function, in the sense that if you're used to specify the section dimensions directly on the ETABS user interface, you are probably assuming these must be inputted in millimeters, but once the API function was prepared for SAP 2000, please be aware you must specify the dimensions in meters. The other function parameters are optional, so you can skip them if you prefer. We will show how to set the next two parameters, that is, the color and the notes, but we would perhaps recommend using default global unique identifier, as that's an internal program setting, which is better to leave as default. By default, the model is displayed by color of objects, that is, color of frames, areas, etc., but ETABS allows to display the model for instance by color of stories, materials and sections. If you revert to the section property definition in ETABS, you can choose the color you want to assign to the section, using the RGB system. Let's choose a random color and make a note of the red, green and blue, which are respectively 48, 52 and 207. We'll use these in a minute, to specify our section property using the API, and we'll then confirm ETABS will assume this blue color when adding the section property to the model. Inside the section property definition in ETABS, there's an option to add any user notes or comments. You can use the string variable notes to include those comments when adding the section property. We'll write something like section added through the API. We're now ready to write our code. This will be quite straightforward now, once we already discussed all the parameters. Let's set variable red is equal to my EtabsModel, instantiating class for frame properties, propFrame, function setRectangle. Open parentheses, to specify the function parameters, starting with the name, which will use the C30x40, followed by the material, which is the C4050. Remember to input section dimensions in meters. So T3 or depth is 0.3, and T2 or width is 0.4. For the optional color parameter, we'll specify the RGB color red 48, green 52 and blue 207. Lastly, we're sending a comment to be added as a note, say section added through the API. The global unique identifier will let the program use default, so we will not use this optional parameter. Close parentheses and hit enter. Add a breakpoint on this latest line of code, as we want to check that the section is not available on the list, prior to the execution of this instruction. Hit the Run Procedure button on your VB editor. Once the grid-only model is populated on ETABS, visit Menu Define, Section Properties, Frame Sections, and confirm section C30x40 is not available on the list of default properties populated on the ETABS model. Execute the line of code. Let's check that section C30x40 is now available inside the frame section properties in the ETABS user interface. Go to Define, Section Properties, Frame Sections. Check that section C30x40 is now showing on the list of available sections for the model. Hit the Modify Show property, so you can confirm name of the section property, and concrete material with grade C4050 as expected. Notice the dimensions were assumed with the correct units. Check that the blue RGB color was assigned in accordance with what was specified on the API function. Lastly, revise the comments imported into the notes parameter. Check that the return value of the API function is 0. Close ETABS and release the objects. These concludes our revision on adding a rectangular frame section to the ETABS model through the API. The next operation we want to illustrate is adding a frame object. The class that includes functions to add frame objects is the cFrameObject interface. Let's load the API documentation and search for this class. There are two possible methods for this, adding the frame specifying the coordinates of its end joints, or, assuming you know the names of the end joints, then you can use function add_by_point instead. We will refer to function add_frame by coordinates, which syntax looks like this. Let's revise the parameters. The first 6 parameters are respectively the XYZ coordinates, of start and end joints of the frame. The name parameter is the default name the program will assign to the frame object, unless user indicates a user-defined name, to supersede the default one. Please notice as this argument is passed by ref on the function syntax. We'll create a new variable to store the name ETABS assigns by default. On the interface, this will be the default unique name of the frame object. The other parameters are optional. The propName parameter allows to specify which existing frame section property you want to assign to the section. We could use this parameter to assign a previously defined section property, as soon as we populate the frame. Once on the next topic, we want to introduce you to the API function that allows to assign a section property to an existing frame object. We'll leave this as default for now. Let's use the username parameter to specify a user-defined name for our frame object. Let's call it for instance column1. When this parameter is used, it will overwrite the name argument of the API function. This will thus overwrite the unique name of the frame object on the ETABS user interface. As mentioned on the function syntax, the program is using the default global coordinate system, so we'll leave as is, and we will thus not use this optional parameter. We're now ready to write our code. Let's declare a string variable to store the default name ETABS assigns to the frame object, on the unique name of the user interface. Our ret variable is now equal to my EtabsModel object, instantiating the frame object class, calling function addFrame by coordinates. Open parentheses, to specify coordinates of start joint, say the origin, 0, 0, 0, followed by end joint with coordinates 0, 0, 3 meters in the z direction. For the name argument, we'll use the variable frame name just defined, which we can use to check default name ETABS assigns to the frame object. Please be aware that you can use the prop name argument to specify an existing section property to be assigned to the frame object while adding it. We could for instance use it to immediately assign previously added section C30 by 40 to the frame object. The parameter is optional, and once we want to demonstrate other options to assign frame section properties, we'll skip it. ETABS will thus assign a program default section property to the frame object, which we will be able to check on the interface, when executing the code. The username parameter is optional, and when used, it overwrites the default name ETABS assigns as the unique name of the frame object added from the API. We will run the code this first time omitting this parameter. We'll then run the instruction a second time, specifying a username, so we can check as ETABS will overwrite the unique name on the user interface. And finally, we will not specify optional parameter for coordinate system, meaning that ETABS will assume global coordinate system by default. Once we are not using the last three optional parameters, just close parentheses and enter. For this example we actually need a next step. When adding the frame through the API, if you want to see it on the ETABS interface, after adding the frame, you need to refresh the view, for it to become visible. We will thus take the opportunity to introduce you to another API class, the cView, which offers function refreshView, which basically refreshes the view of the working window. So let's add that instruction on our code. Use the myEtabsModel object to instantiate class view, function refreshView. We're now ready to test our code. Hit the run procedure on VB. For an enhanced view of the element, let's close one of the working windows and zoom in on the location where the frame object was added. If you right-click on it, you can check that ETABS assigned a default unique name to the frame object, called simply 1. Additionally, notice as ETABS assigned a default section property. This is a section called W14 by 500, which is an I-shaped steel section property, imported from the US database of steel profiles. We can also check that the current value of variable frame name is the default unique name ETABS assigned to the frame object, which in this case it's just 1. Check returned value of the API function. Close ETABS and release the objects. Before moving forward, we want to showcase one last option, which is referring to the username optional argument, and specify a user-defined unique name for the frame object. We will adjust the code accordingly for that purpose. Skip the section property parameter, but assume username column 1. Close parentheses, thus skipping parameter for coordinate system. Run the procedure again. Check as the frame unique name of the frame object has now been revised, according to parameter username specified for the API function, which is now reflected on the unique name of the frame, showing as column 1. You can also check as the value of the variable frame name has been updated to reflect this, also now showing as column 1. Check that return value of API function is 0. Close ETABS and release the objects. This concludes our revision on how to add a frame object on the ETABS model, using the API. On this next step, we'll assign an existing frame section to the frame just created. We'll use the frame section property C40 by 30, created on previous step 13. We'll continue to work with the class for the frame objects, the cFrameObject interface, which is basically the class that includes the methods to manipulate frame objects. To give you some examples, besides functions to add frame objects, you'll also find options to delete frames, delete different types of loads, such as distributed loads, point loads, and temperature loads. Or, if instead of wanting to delete the loads, you want to assign them, then you can revert to functions to add distributed loads, point loads, and temperature loads. That being said, from all the long list of possible methods offered by this class, the one we'll require in order to perform the next operation is the set section. This is how the function syntax looks like. Let's have a look at the list of parameters. At this instance, we will disregard the optional parameters, and focus only on the first two mandatory parameters, which are the name, and the property name. These stand respectively for the name of the frame object to which we want to assign a section property, and the name of the section property to use. For our example, we will use frame object with unique name column 1 just created on previous step, and we will assign section C30 by 40 to it. We're now ready to add the code. Let's set ret variable now equals to my ETABSModel object, instantiating class cFrameObject, calling function setSection. Open parentheses, to add function parameters, starting with the name of the frame object, which is our frame with unique name column 1, followed by frame section property name parameter, which will specify the C30 by 40. At this instance, we'll ignore all the optional function parameters, so close parentheses and enter. Please note as we move the instruction to refresh view below the instruction to assign the revised section, so we can check the revised section property was correctly assigned after running the code. Add breakpoints on the code, before and after assigning the C30 by 40 section. This way, we can check the original section assigned by default by ETABS, followed by the revised section assigned through the API. Hit the Run Procedure button. Zoom in on the location where the frame object was added. If you right-click on it, you can check that it has the unique name column 1, which was assigned using previous API function addFrame by coordinates. Moreover, you can confirm that currently, the frame still has section W14 by 500 assigned to it. As a reminder, this was the default section property assigned by ETABS. Run one more line of code, in order to assign the revised section property. With the last instruction we just added to the code, you can confirm the frame now has section property C30 by 40 assigned to it. Check returned value of the API function. Close ETABS and release the objects. This concludes our revision on how to assign a previously defined section property to an existing frame object on the ETABS model, using the API. The last example we want to show you is how to access the tables of the interactive database through the API. For that purpose, we'll assign the section property C30 by 40 to the frame section, but instead of using options illustrated on previous steps, which included specifying the section property immediately as a parameter on the addFrame by coordinates function, or using the setSection function. We'll now show you how to access the tables of the interactive database, using the API, in this case, with the purpose of assigning an existing frame section property to a frame object. Start by deactivating the previous line of code, where you were assigning the section property, using the API function setSection. This action will force ETABS to assign a default section property to the frame object. Now that the code is skipping the setSection instruction, we can run the code, and check what section property ETABS is automatically assigning to the frame object. As you can confirm on screen, ETABS assigned a default section property to the frame object. This check is just so we can make sure that the default section property currently assigned to the frame object is not the C30 by 40. Next, let's investigate the table of interest under menu Edit, Interactive Database. Under the Frame Assignments, Frame Item Assignments node, we want to expose Table Frame Assignments, Section Properties. ETABS populates the table on screen. We can check that currently the table has only one line with information, corresponding to the only frame object that exists on the model. If you anticipate that you'll want to access any particular table of the interactive database through the API, it is paramount that you understand all the information of the table, including the name of the table, the number of lines of information, how many columns of information it displays, and what information is stored in each column. For our particular example, the table has only one line, and 3 columns. The first column lists the unique name of the frame object. The second column checks if the frame is included on any existing auto-select lists. This is something that we haven't discussed yet, but for the time being, just make a note that this parameter is set to no auto-select list or NA. The third column indicates what section property is assigned to the frame object. Our goal is precisely to overwrite this last information, by editing the table through the API. Let's see how. A new class, called cDatabaseTables, was added to the API for the purpose of expanding the editing capability over tables. Once we already know exactly which table we want to access, we will start by using an API function to call a single table in an array format. This is method getTable for editing array, of class cDatabaseTables. This is how the function syntax looks like. Let's now focus our attention on the parameters of the function. Starting with the table key. This is the name of the table to be edited. On our example, the name of the table is Frame Assignments, Section Properties. Please notice as the parameter group name is currently not in use. The table version parameter is returned by the program, and refers to the version number of the specified table. Parameter fields keys included is an array, which in this context can be interpreted as a vector, containing the column headers, which describe the information stored on each column of the table to be edited. Please notice as the API uses zero-based arrays, which means the first data is stored on position 0 of the array. Users are recommended to check page programming concepts used in the CSI API of the documentation, for additional information on the way ETABS considers arrays. For our example, if we refer to table frame assignments, section properties, this would be an array with 3 positions, where position 0 is unique name, position 1 is auto-select list, and position 2 is section property. The number records parameter is the number of records of data returned for each field, which in other words, is essentially the number of rows of data. In our case we have only one line, so one record for each field. Let's now revise the parameter table data. It is important that you fully understand this parameter, as this describes the logic with which the API stores the data from the table retrieved from the interactive database. If you read the example described on the parameter, you'll understand that you need to look at each row of information, and put it in a corresponding transposed vector. For our example, the table data vector will look something like this, where position 0 stores the frame object unique name, position 1 stores the information of the auto-select, and lastly, position 2 stores the current section property assigned to the frame object identified by its unique name. We have only one line of information, but if we had more frames, then you'd repeat the process described of transposing the information from line into column for each frame, and you'd move the vector of each frame sequentially one below the other, so much so, that you'd end up with a zero-based vector, or array, with as many positions as the number of fields included, times the number of records. Please refer to the example described on the parameter, which illustrates this for a table with 5 rows. Please also note that the table data array doesn't include the information of the column headers, once that is already stored on parameter fields keys included, described a moment ago. Now that we've carefully revised all the parameters of the function, we're ready to add our code to retrieve the information of table frame assignments, section properties and edit the record of field section property. Start by creating the variables required for the function. These include the strings table key and group name, though as a reminder, the group name parameter is currently not in use. There's a caveat you need to be aware, so you can use the function, which is that variables table version and number record should in fact be defined as long, instead of integer, to avoid compilation errors. This is a small glitch on the API documentation. Finally, let's define our string arrays, the one containing the columns headers, which is the fields keys included, and the one containing the records of information, which is the table data. Now we need to indicate which table we want to retrieve from the interactive database. This is table frame assignments, section properties. Let's set variable ret equals my EtabsModel, instantiating class database tables, calling function getTable for editing array. Add all the parameters, as per previous instructions. It's important to clarify that this instruction only retrieves the current table from the interactive database, but it doesn't change it. We know that currently, the frame section property assigned to the frame object is the W14 by 500, and that this record is stored on position 2 of our table data array. We can now tweak the record on the code, by setting position 2 of the table data array equal to C30 by 40. Once the record is changed, let's use API function from the C database tables class, that allows to set table for editing array. This function reads the current records of the table data, and stores them until the user either specifies that the table is to be applied to the model, or that the operation is to be cancelled. The parameters of the function should now be self-explanatory, they're basically similar to previous function. Let's call this function to store our revised array. Let's set variable ret equals my EtabsModel object, instantiating class C database tables, calling function setTable for editing array. Add all the parameters, as per previous instructions. The final instruction required now, is sending this revised information, to update the table of the interactive database in ETABS. The function which will enable this action, is the apply edited tables from class C database tables. To give us a bit of context, the action of this function is similar to the retrieve table from Excel, which we had the opportunity to illustrate on previous video for the interactive database. Basically, Once you're applying changes to the program database, the program checks if it encounters any import errors or warnings, which will then become listed on the import log file. On screen, we're showing a snippet of the log file, which you might remember from previous lecture. The first parameter of this function, the fill import log, is a boolean variable, that is, it can only assume values true or false. There's a comment on the parameter, highlighting the fact that the import log file can be very large. In light of this, setting this parameter to false offers the user the possibility to avoid filling the import log. The number of fatal errors, number of error messages, number of warning messages, and number of information messages contain the information highlighted on snippet from the import log shown on screen. Please notice as all these are arguments passed by ref to the function, and are returned by the program. The import log string variable contains the import log file itself. We're now ready to write the code for this function. Start by declaring the required variables to store messages of the import log file. A note to stress that same as previous database table functions illustrated before, these also show as integer type on the syntax of the function, but they are in fact declared as long. Declare all four variables, that is, the number of fatal errors, the number of error messages, the number of warning messages, and the number of information messages. Lastly, declare the string variable for the import log file. Now we're ready to call the function. Let's set variable ret equals my ETABSModel object, instantiating class database tables, calling function apply edited tables. Let's set argument fill import log to true, so we can get the import log file when executing this instruction. Add all the other parameters as required. As we're approaching the end of the instructions of this procedure, let's add a final instruction on our code to save the model, by setting variable ret equals my ETABSModel object, instantiating class file, calling function save, argument model path. For your reference, the model path variable was previously described on step 4 of this worked example. We're now ready to test our final code. Add a breakpoint on the instruction to access the tables of the interactive database, thus allowing us to check the current section property of the frame object, immediately before we force the assignment of a different section property through the API. Hit the Run Procedure button on your VB editor. As soon as the model is populated on screen for you, please zoom in on the location where the frame object was added. As you can confirm on screen, currently the frame object is an ETABS default assigned section property, the W14x500. This can be verified here on the Object Information window, or we can also revert to the interactive database and expose corresponding table, frame assignments, section properties. At the moment and as expected, the table shows that current section property assigned to frame object with unique name column 1 is the ETABS default W14x500. Let's execute one more line of code. Please note as variable table key now has the information of what table should it retrieve from the interactive database. The next line thus instructs to retrieve the current frame assignments, section properties table from the interactive database. As soon as this task is completed, you can use a VB watch to check current values stored on array table data. This debugging tool is very useful, as it will allow us to check the values stored on the array at every instance. Particularly for the scope of our example, we will be able to check in a minute, as it will update to reflect the information for the revised section property. Please notice as at the moment, you can verify that position 2 of array table data lists section property W14x500, which corresponds to the default section ETABS assigned to the frame object. Before moving forward, make sure that current value of ret variable is 0, corresponding to the return value of API call getTable for editing array. Execute the next line of code, which instructs to change record for field section property, stored on position 2 of the table data array, from current W14x500, to revised C30x40. Note that as soon as instruction is processed, the VB watch for the table data array immediately displays the revised information. Add another breakpoint to stop the code just before it updates the revised table on ETABS, and execute one more line of code. As a reminder, the function setTable for editing array reads the current records of the table data array, and stores them until the user either specifies that the table is to be applied to the model, or that the operation is to be cancelled. For our example, we will apply the stored updated information to the model with the next instruction, by referring to function apply edited tables. Confirm that current value of ret variable is 0, corresponding to the return value of API call setTable for editing array. Add one more breakpoint, just before instruction to save the model. Execute the next line of code. With this last instruction, we applied the changes on table frame assignments, section properties, on the interactive database of ETABS. As you can confirm on screen, currently the frame object already has the revised frame section property C30/40, assigned through the API. This can also be verified on the interactive database, by exposing table frame assignments, section properties. The table now shows that current section property assigned to frame object with unique name column 1, is the C30/40, which was assigned via editing of the interactive database, using the API class C database tables. Confirm that current value of ret variable is 0, corresponding to the return value of API call apply edited tables. Check that variables for number of errors, warning and information are 0, thus explaining why the import log file was not created. As we're approaching the end of the procedure, we're instructing the program to save the file created on step 4, inside folder created for that effect, called CSI ETABS API example 2. Please note as once the line of code is executed, both the EDB and the E2K text files become available inside the folder. Close ETABS and release the objects. This concludes our revision on how to access the interactive database through the API. A final note to let you know that we are providing the macro-enabled Excel file, including the code of the worked examples prepared on this lecture, on our Structural Academy website. Please refer to additional information on description box of video below for this. Using the API is a broad topic, from which we've barely scratched the surface. That being said, we all need to learn how to walk before we can run. Hopefully, this lecture was enough to give you at least a starting point on what you can do with the API and how far you can get. Thank you so much for watching. If you like this video, please don't forget to give us that thumbs up, so this video can spread to more people. If you want to check the next video on this series, you can visit it here. Check out our website, structuralacademy.com, for additional information on all the other courses we offer. And stay tuned on our channel for all our latest content.